Example number 4, comparing two sinusoidal functions. Alexis and Colin own a car and a pickup truck. They notice that the odometers of the two vehicles gave different values for the same distance. As a part of their investigation into the cause, they put a chalk mark on the outer edge of the tire on each vehicle. The following graphs show the height of the tires as they rotated while the vehicles were driven at the same slow, constant speed. What can you determine about the characteristics from these tires? So, first things first, let's talk about what the range is. Let's talk about what the the equation of the midline. Let's talk about the amplitude. Let's talk about the period for each. So I'm just going to do the work underneath each graph. So the range for this one is going to go between 0 and 24 inches. 0 less than or equal to y less than or equal to 24. I'm going to say y and x, and same thing here, y and x, so we know what we're talking about. Whereas the range here goes from 0 to 32. 0 is less than or equal to y is less than or equal to 32. So clearly, the pickup truck has a bigger sized wheel. Let's talk about the equation of the midline. So I have y equals maximum plus minimum divided by 2, 24 plus 0 divided by 2. So the equation of the midline is at 12. So what we can say is our axle actually is right at 12, because that's when we're talking about the height of the tire, this is one part of the tire, right? It's 24 at the maximum, and then it goes down and it touches the ground, and then the chalk part, the chalk marking goes back up to the maximum on top and then goes back down. So our axle right here is at our minimum. Equation of midline. Here it's going to be y equals 32 plus 0. So the maximum happens at 32, the minimum happens at 0, divided by 2. So y equals 16. So right off the hop, we know that the pickup truck, not only does it have bigger wheels, but it makes sense that the pickup truck will be higher off the ground than, say the car. In all honesty, the amplitude doesn't help us all that much, because we kind of figured it out from just analyzing the range and the equation of the midline. We have a good sense of how large these tires are, but let's move on to the period. So the period is going to be from maximum to maximum or minimum to minimum. I'm going to go from maximum to maximum. So we have, and remember it's in the x direction, so the distance, the horizontal distance between the two maximums is going to be 2.4 minus 1.2, which is going to be 1.2 seconds. So for the car wheel to rotate once around, it's going to get to take the car wheel to rotate once around is going to take 1.2 seconds. What about for the truck? So we can't really go from maximum to maximum. I mean, we could here, but when we get too close to data that we don't know, like it's very clear that this right here is a minimum and this one right here is a minimum. So let's go with that. So the horizontal distance between there is going to be 2.4 minus 0.8. So that is going to be 1.6 seconds, because we're going to use this. So it takes 1.6 seconds for the tire to rotate once, for that chalk marking to be at the bottom of the tire, for it to roll forward, and to have it back down. So it would go back down on the ground.